Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through delta star transformation problems. It said determine the total resistance of the circuit below. I have this electrical network here. You have to find the total resistance. So let's see how we can apply delta star transformation to solve this problem. In our previous lesson, we went through how to convert a delta to star and a star to delta respectively. So let's see how we can apply that. To solve this, let's redraw the circuit widely. So we have a 6 ohm resistor up. We also have another 6 ohm going into another 6 ohm, right? So a branch 3 ohm and a branch 3 ohm. I have one here. So this is my A and this is my B, right? So at this point, if you want to simplify, let me rewrite my 6 ohm here, 6 ohm here, 6 ohm here, 3 ohms, then 3 ohms. If you want to simplify this circuit, you ask yourself, which of these resistors are in series or parallel? But in our previous lessons, as you've learned, whenever you are simplifying any electrical network, you take two resistors at a time, right? So you realize that if I take any resistor here, when I take any resistor here, there are nodes here. So 6 ohm and 3 ohm. Because of this node, they can't be in series. When I traverse through their paths, I'll come and meet this 3 ohm resistor, meaning the two of them are not in series nor parallel. And we can try that for all the different resistors here. You realize that none of them will be in series or parallel. This is a typical problem for delta star transformation. What do? We can clearly see that 6 ohm here, 6 ohm here, 3 ohm here is in a is in a star shape, right? Like a star, right? Now you can see that 6 ohm here, 6 ohm here, 6 ohm here is in a delta shape. Likewise, 6 ohm, 3 ohm, 3 ohm is also in a delta shape. So how then do we simplify this to give to get our required circuit diagram for simplification? The rule is simple. Convert any of them either delta to star or star to delta, and your problem will be solved. So let's convert the first delta to star, okay? So that's the approach we're using. Now, next problem, we convert star to delta and we see. So converting this delta 6 ohm, 6 ohm, 6 ohm to star, you will introduce electrical resistance. You will introduce a resistor in between any two. So in between this 6 ohm and 6 ohm, I will introduce a resistor, right? And that resistor will have a label. Between this and this, I'll introduce another resistor here. And between this, I'll introduce another resistor like this, right? So I'll have this resistor labeled A, this resistor labeled B, and this resistor labeled C. Once you have this, you are going to redraw the circuit. But before you redraw the circuit, you need to find the values of A, B, and C, okay? So to find the values of A is simply equal to, when you have a resistor in between any two resistors in a delta, you simply multiply the two resistors, then all over the sum of all the other resistors. So see the formula. Is simply equal to 6 times 6 over 6 plus 6 plus 6, okay? This gives 36 over 18, and that is perfectly equal to 2, right? Then you can have B. So realize that B will also be equal to, all of them are 660, so B is also going to be equal to simply 6 by 6 all over 6 plus 6 plus 6, right? Then that will also give us 2. So likewise, you have the same for C, because C is also between 6 and 6, so C will also be equal to 6 by 6 all over 6 plus 6 plus 6, and that will also give us 2. So now that you've gotten all to be 2, let's redraw the circuit by replacing our delta with the star. So watch closely. To redraw the circuit, we are simply going to reproduce what you have here. And now check, we are going to use what you are seeing here. How do we remove the 6 ohm, 6 ohm, 6 ohm? So check, from the A, I'll have my A, right? Now, when I move up, I'm now going to pass the branch of A, B, and C. So I'll move up, right? Then my A will come, right? Then my C2 will come. Then I'll have my B here coming. You can see I've ignored the 6 ohm here, right? So I can come down. So this 6 ohm and this 6 ohm will also vanish away because I've already converted, right? Then after you can have this side. So there's nothing here. Just picture it that way. There's nothing here. But this here, you just bring it to the 3 ohm. So this will move down to the 3 ohm, and this will also move down to the 3 ohm because there's nothing there. So now we can write it this way. We can have our A 2 ohm, our B 2 ohm, our C 2 ohm. This is 3 ohm, right? Then this is also 3 ohm. Let's join the circuit and see how what you are getting. So joining the circuit, I'm simply going to join this to this, and this goes to my B, right? At this point, looking at this structure, simplification can be easy. You can see 2 ohm and 3 ohm are in series, right? These 2 ohm and these 2 ohm are also in series, the same current will pass through. So I'll simply combine the two of them. So this will give me, this is the structure. I have my A going into, these 2 ohm is not affected, so my A will go into the first ohm, then it will branch. Now 2 plus 2 will give us 5, right? So in this branch, you have a 5 ohm coming down to B. Then it's also going to the other one, combine like that. So you can clearly see that you have 2 ohm here, then you have, here is 2 plus 3, 2 plus 3, so 5 ohm, we have 5 ohms, right? So at this point, this is what we have gotten. So you are going to simply see that your 5 ohm here and 5 ohm here will be in parallel, starting away from the terminal. So since they're in parallel, there is a node here, and when you traverse through them, they are the only two resistors you are seeing. So we simplify them. So you realize that 5 is parallel to 5. That gives us 5 by 5 over 5 plus 5. And that's giving us 2.5 ohms. I redraw the circuit, and I have my A, terminal A, going into my 2 ohm, coming down to my 2.5, then coming down to my terminal B. As simple as that. So I have my 2 ohm, then I have my 2.5 ohm, as you can see clearly. So right now you can see that the resistance between A and B is simply equal to 2 ohms plus 2.5 ohms, and that gives us 4.5 ohms. So this is all I have for you in this video. In the next video, I'll show you how you can convert a star radar to a delta in order to solve a similar problem. So see you then.